Alright, what's up guys? In this video we're going to pick up some calculus here. We're going to evaluate a trigonometric limit. So we're asked to evaluate the limit as x goes to 0 for secant of 2x minus 1 all over 5x. So the first thing you do for any limit is just substitute the value in and see what happens. So remember, if we substitute the value in, we'll get secant of 0 minus 1. Remember, secant of 0 is 1, so we'll have 1 minus 1, which is 0. And obviously we'll get 0 in the denominator as well. So we'll get that indeterminate form, 0 over 0. And remember, indeterminate form doesn't mean that the limit does not exist, just means that you got to come up with a clever way of finding the limit. And there's a bunch of different things that you can attempt to see if you can get the limit here. In our particular case, I don't really see where with this trig limit we can use any particular type of trig identity or anything. So let's just use L'Hopital's rule, and we'll see if that will help us out a little bit. So remember what L'Hopital's rule basically says is that if you have a function divided by another and you end up getting 0 over 0 or infinity over infinity, basically what L'Hopital's rule says is that you can take the derivative of the top and the bottom and substitute the value that in our particular case x is approaching again, and see if you can get out a finite value. If you don't, the great thing about L'Hopital's rule is that you can use it over and over again. That's the great thing about L'Hopital's rule. So let's just use L'Hopital's rule here. So let's separately take the derivatives over here. So let's take the derivative with respect to x of secant of 2x minus 1. Well, remember the derivative of secant of 2x, we'll use the chain rule. That's just going to be secant of 2x multiplied by tangent of 2x multiplied by 2, because the derivative of secant of x is secant of x times tangent of x. So therefore the derivative of secant of 2x is secant of 2x times tangent of 2x, and then the chain rule says take the derivative of the inside with respect to x multiplied by 2, and we'll simply get 2 secant of 2x multiplied by tangent of 2x. That's the derivative for the top. And obviously if we take the derivative of the bottom, which is 5x, with respect to x, we just get 5. So now let's do it again. So we'll get the limit as x goes to 0. And we get 2 secant of 2x multiplied by tangent of 2x. And we'll divide all of that by 5. And we stick the 0 in there again, and we know it's going to work this time. So if we stick in a 0, we'll get basically 2 times secant of 0 times tangent of 0. Secant of 0 is 1, but tangent of 0 is 0. So we're going to get 0 in the numerator and 5 in the denominator, and which 0 and 5 just gives us 0. So the limit here is going to be 0. And that's our answer to our trigonometric limit. Keep in mind that this is a common mistake that a lot of students make. Just a little bit of, rephrase this a little bit here so you guys can understand it. It's important to not always assume that every place you sub in a 0, you always get a 0 out. A lot of students assume that. Now, if I multiply anything by 0, I'll get 0. But let me just give you a couple examples. So remember that secant of 0, that's 1. Secant squared of 0 is also 1. Cosine of 0 is 1. And e to the 0 is also 1. So it's important to know that sticking a 0 in for something all the time doesn't always yield out a 0. Okay, that's not always the case. That's just a couple of examples. I'm pretty sure there are some others. So keep that in mind. That's something that's very important that a lot of students assume. You know, I stick in a 0, I'm going to get 0 out. Nah, it doesn't work like that all the time. So keep that in mind, and you'll be good to go on that. So, all right, so that's a trigonometric limit, and hopefully that makes sense. So let me know if you got any questions, and I'll see you next time.